Hi, this is Group 5 of Biomedical Engineers, and today we're doing circuits, specifically circuit problem number 1, which will be shown on the next slide. So group members are Garrett Kane, which is me, Evan Augustine, and Samantha Vargas. Okay, so here's the problem. For the following circuit, voltage of A is equal to 140 volts, voltage of C is equal to negative 140 volts, current of A is equal to 75 amps, and current of C is equal to 15 amps. So all three devices shown in the circuit can be modeled as a resistor. So we need to find the power absorbed by B and the resistance values for each device. So something to note here is that because, as indicated by our problem, resistor B is absorbing the power of the circuit, that must mean that A and C are going to be supplying the power to the circuit. Okay, so we have the unknowns and knowns. So for the given or the knowns, we have voltage of resistor A is equal to 140 volts, voltage of resistor C is equal to negative 140 volts, the current of resistor A is equal to 75 amps, the current of resistor C is equal to 15 amps. So for the unknowns, or what we're going to solve for, the voltage and current of resistor B, which will give us the power absorbed by resistor B, and resistance values of all the resistors. Okay, so first we're going to be solving for the voltage of resistor B. So to do this, we have to use KVL, or Kirchhoff's voltage law, to find the voltage of resistor B. So KVL says that across an entire loop, the resistors must be equal to 0 for the voltage. So then we can say algebraically that voltage of C plus voltage of B is equal to 0. And because we know C is negative 140 volts, we can plug it in here to get negative 140 V plus VB equals 0. And when we solve for VB, we need to get this to the right side, just to add it. And we get voltage of B is equal to 140 V.
Alright, we're going to be solving for the current of resistor B. We must use Kirchhoff's current law to find the current of resistor B. The KCL definition. In a parallel path, the current entering a junction is equal to the current leaving the junction. Since resistor B is parallel to the circuit, it is the input, and resistor A and C are the outputs. Thus, current of resistor B equals the current of resistor A plus current of resistor C. IB equals IA plus IC. IB equals 75A plus 15A. So the voltage of current B equals 90A. Now we're going to be solving for the power of resistor B. The power absorbed by a resistor can be demonstrated by the power formula P equals VI, where P equals power in watts, V equals voltage in volts, I equals current in amps. Now, using the previous info from the two slides, we can plug this in to solve for power. PB equals VB IB. PB equals 140V times 90A. So the power of resistor B equals 12,600 watts. The power absorbed by resistor B is 12,600 watts.
Okay, so now we can solve for the resistance values of each resistor. So to do this, we need to use Ohm's law. And Ohm's law describes the relationship between voltage, current, and resistance of a given circuit. So if we rearrange this from V equals IR, we can get R equals VI. And this is what we want because we already know voltage and current. So for the first one, we're going to do RA equals VA over IA is equal to 140 volts over 75 amps, which is equal to 1.87 ohms. So that is the resistance value of resistor A. And for the second one, we have RB equals VB over IB equals 140 volts over 90 amps, which is equal to 1.56 ohms. So that is the resistance value of resistor B. And RC equals VC over IC is equal to negative 140 volts over 15 amps, which is equal to negative 9.33 ohms. But because resistance can't really be negative, we're going to say the magnitude of that will be equal to 9.33 ohms. Okay, so if we can conclude anything from this, we can start by saying that the circuit is being supplied by resistors A and C and absorbed by resistor B. I explained this in the second slide also. So now we can also say that the powers of A and C must be added together to be supplied for the absorption process of resistor B. Okay, so if we do the math for powers of resistors A and C, we should find them totaling to the power of resistor B. So PA equals 140 volts over 75 amps, which is 10,500 watts, and PC equals negative 140 volts over 15 amps is equal to 2,100 watts. So if we add these together, we'll get 12,600 watts. Also, for PC, it should be negative 2,100, but because the power has to usually be positive, we're going to say the magnitude. So when we add these together, it gets 12,600, so that makes sense. So in a real world application, we can say this makes sense, this part right here, because we know that the basic laws of the universe are said to say that energy cannot be created nor destroyed. So when you supply something, that must be equal to what it is absorbed by, because there's no external forces that are involved in this. That is it. So it's a great recap for AP Physics, I must say.